Dear students, in previous sessions of this chapter, set theory or set C for short, you have learnt about the definition of a set, the notation and the two ways of representing a set, and then the types of sets, and we worked out problems connected with all of them. That is two methods of representation of a set would be, one is a roster form, the other one is the rule method, what we say. That means roster means we actually write the elements, the rule method means we just give the rule that has to be satisfied by all the elements, and we can convert one from the other one. That is, if it is given in the roster form, you can write it in the rule method. A rule method, you can convert that into roster form. Then we learnt about the types of sets. That is, if a set does not contain any element, then we call it as a null set or an empty set or a void set, and we use the notation phi or the empty brackets to denote a null set. Then singleton. What do you mean by singleton? The word itself says that it contains only one element. Now next is finite. That is, if a set contains finite number of elements. Finite means we will be knowing the exact number. The number may be a very huge number. Even then we call it as a finite set because we will be knowing the exact number of elements present in the set. If we do not know the exact number, or if it is containing an infinite number of elements, no, we call it as an infinite set. So these are the things we have learnt in the previous sessions, and now we move on to the next one. Here the next topic of the same set is subsets. It is subsets. Now let me consider two sets here. Take a set A containing the element say 1, 2, 3. Take another set B containing the elements 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You observe, in the set A we have got 3 elements. In the set B we have got 5 elements. And each element of A, that is 1, is present in A, it is also present in B. 2 is present in A, it is also present in B. 3 is present in A, or 3 belongs to A, 3 also is belonging to B. That means that all the 3 elements of the set A, they are also present in the set B. That means I can say this set A is a part of the set B. So in general, if an element belonging to a set A is also an element of another set B, we say that A is a subset of B. That is, it is a part of that one. So if A, small letter E, let me take a general element. If A belongs to A, then A belongs to B also. If an element belonging to A also belongs to another set B, then we say A is a subset of B, and the notation is write A, and this is the notation. If A belongs to A implies A belongs to B, then we say A is a capital A is a subset of B. So when you use the notation belongs to, this has to be an element or small letter B used. Here it is a notation for the word subset. Okay, so A is a subset of B. Suppose A is not a subset of B. Suppose it contains some other elements, say 2, 3, 8, 9 like this. You observe that 2 and 3 are present there, but 8 and 9 they are not present. So, and we say A cannot be taken as a subset of B. In that case, now we write this and cancel this one. The usual notation, equal, not equal, less than, not less than, like that. The same notation we will be using. So, if each element of A is in B also, another set B, we call it as a subset. First one is a subset of the second set here, and this is the notation. If A is not a subset of another set B, we say A is not a subset, write the same notation, just to cancel it. And generally we write like this: if A is a subset of B, we use this notation, write 2 lines and write an arrow mark. This is for implies. Implies means whatever we write afterwards now is obtained from this one. This implies that, this gives that, that is the meaning of that one. A is a subset of B implies that A belongs to A implies A belongs to B also. That is the meaning of that one. A is a subset of B. A is a subset of B implies A belongs to A implies A is belonging to B also. Now, this is the notation we use for the subset. So, when you write two parallel lines and an arrow mark, implies means first one, the second result is implied by this one. In other words, from the first result we get the second result. That is the meaning of that one. Now, suppose I have like this. If A is a subset of B, what do you mean by that one? A, each element belonging to A is also belonging to B. That is the meaning. And suppose B is also a subset of A. Let us assume A is a subset of B. That means that each element belonging to A also belongs to B. Suppose it happens that in this particular example, suppose each element belonging to B is also an element of A. In other words, if A is a subset of B and B is a subset of A, these both of them together imply that A is equal to B. That means that both of them have got the same elements. That is the meaning of that one. If A is a subset of B and B is a subset of A, implies both A and B are equal to each other. In the previous session already we have discussed about the equal sets, and this is the notation we use, the usual equality sign. When do we say that two sets are equal? When the two sets are said to be equal when they contain the same elements. Not same number of elements, when they contain the same elements. That means that A is a subset of B and B is a subset of A. We use the notation like this. If A is a subset of B and B is a subset of A, now we write an arrow mark, parallel lines and arrow mark on both the sides. This is read as implies and implied by. Okay, that means this implies that one and this is implied by the right hand side part. That means that A is equal to B. This is also read in two ways. One is implies and implied by, that is this implies that and this is implied by that one. That is one way. Or we use another word, if and only if. That's also called as necessary and sufficient condition. If and only if. See, this is the two ways it can be read, implies and implied by, or we say that also if and only if. For short we write IFF, if and only if. So though we write IFF, it has to be read as if and only if. Okay, that is the two ways of expressing the reading the same notation. That means that if A is a subset of B, B is a subset of A, implies A is equal to B. Now, if A is equal to B, then we can say A is a subset of B and B is a subset of A. That is why I have written arrow mark on both the sides. So, it is implies and implied by, or if and only if. And briefly we write IFF. Now, that means that I will take an example. Suppose A contains two elements 1, 3, and let me take B containing 3, 1, 1, 3, 3, 1. It's only a collection. No order is important here. Now we observe that each element belonging to A is an element of B. That means that A is a subset of B. You take in the reverse order. Each element belonging to B is also an element of A. That means that B can also be taken as a subset of A. Together we see that A has two elements, B also is having the same two elements. So I can write that A is equal to B. So that is the meaning of this one. So by taking an example, always the idea becomes clear. Now this is about the definition and the notation of a subset. Now let me take the standard sets which you learnt in the very first session of set theory. I had mentioned about some standard set. What are they? First one is N, the set of the natural numbers. Natural number means 1, 2, 3, 4, 5, 6, 7, etc. Okay. Next is the set of integers. We denote it as I or Z. Any one notation you can use. Z means it is a set of integers. When I say integers, it can be positive, it can be negative, and 0 is also included. Next was the set of the rational numbers. Now, the next we discussed was the set of the real numbers. These are the 4 standard sets. In the very first session, I had mentioned after giving you the definition of the set here. All of them are collection of numbers, isn't it? Same type of numbers. This contains only the natural numbers, this contains only the integer, this contains only the rational number, this contains only the real numbers. Now let me say, natural number means 1, 2, 3, 4, etc. You observe they are also integers, isn't it? So I can say that means that the set of natural numbers is a part of the set of the integers, isn't it? Now set of integers, what are they? 0, plus or minus 1, plus or minus 2, etc., etc. They are negative, they are positive as well as 0. Now you observe what's the definition of a rational number. A rational number is defined like this. Q is the set of number all x such that x is equal to p by q, where p and q are integers and q not equal to 0. Now this is the definition of the rational number. The set Q contains all x such that x is equal to p by q. What are p and q? They are integers. Only condition is the denominator or the q should not be equal to 0, because division by 0 is not defined at all, isn't it? Now you observe all these numbers now can be written in the form of a rational number. For example, 1 can be written as 1 by 1. Minus 1 can be written as minus 1 by 1, and 2 can be written as 2 by 1 or minus 2 by 1. 0 can also be written 0 by 1. That means that each and every integer, negative, positive or 0, can always be expressed in the form of a rational number. So, using this one, I can say that the set of rational numbers, all the numbers that we the set of integers would be a part of the set of rational numbers, since each integer can be considered as a rational number. Now, real number. See, real number, what is the definition of a real number? Real number means it contains all rational and irrational number. Rational number we have discussed, that is any number which can be written in the form of p by q is called a rational number. Any number which is not rational is an irrational number. Now this real number, the set of real number contains all rational as well as irrational number. In other words, the set Q is a subset of or the set of the real numbers. Sometimes these are the standard notation: natural numbers, set of integers, set of rational numbers. Sometimes the set of irrational numbers, some teachers denote it as Q dash, but it is not a standard notation. So different people use different notation here. Suppose I take Q dash to be the set of the irrational numbers, then it is also a subset of the set of the real numbers. Okay, so this is how we write. So there is a connection here. This is a subset of this is a subset of this, and this is a subset of this. So for the time till you have learnt up to real number here. So all these they become a part of this one. So in this discussion, this becomes the biggest set which contains all of them, which consists of all types of numbers we have discussed so far. Now this is the notation we use here. Now there is one more definition. Here generally I have told you a subset. Subset means if each element belonging to a set A also belongs to another set B, we say the first set is a subset of the second set. Now let me consider set A containing 1, 3, 5. Now set B, let it contain 1, 3, 5, 7. Now you observe here A is a subset of B, correct? A is a subset of, because A 1 belongs to A, 1 belongs to B, 3 belongs to A, 3 belongs to B, 5 belongs to A, and 5 also belongs to B. And A is a part of the set B, therefore A is a subset of B. But look here, apart from the 3 elements, B has got one more element. So here A is a subset of B and A is not equal to B. isn't it? So in the previous, just now I told you, if A is a subset of B and B is a subset of A, then A would be equal to B. They contain the same elements. Here I am considering an example where A is a subset of B, but A is not equal to B. That means that if there is at least one element in B which is not present in A, then we call A as a proper subset of, it is a proper subset of B. That is what we say. Now A is a subset of B. Generally we say if each element of A is belonging to the set B, we say A is a subset of B. Now this is the next part. If A is a subset of B and A is not equal to B, that means A is strictly a part of the set B, then we call A as a proper subset of B and B is called as a superset of A. A is a proper subset of B and B is a superset. Superset means more than that, above that. That's the meaning of that one. So if A is a subset of B and A is not equal to B, we say A is a proper subset of B. That means here this is B is also called as the superset of A. Now usually problems on this would be either 2 or 3 mark questions you can expect. That is, you will be given a set containing some elements. You will be asked to write all the subsets possible for that particular set. That is, write all the subsets of that one. If there are only 2 or 3 elements, you can expect it for a 2 mark question. If there are 4 elements, it is given for a 3 mark question. Usually we do that one. Now consider some set A. I am not writing any element here, some general set A here. Now for each set A, irrespective of the number of elements present in that one, A itself would be a subset of that one. That is, you can write A is a subset of A because each set will have itself as a subset. That is, each element of A certainly will be in the set A. Therefore, for any set A, I am not saying anything about the elements here, how many elements are the number of elements I am not specifying. Consider a general set, it may contain any number of elements. Now it will have minimum 2 subsets, that's the meaning here. That is, the set itself is a subset and the null set is always a subset, or the phi, what I denote it as phi. So for any set A, these 2 will always be there. The set itself is a subset of that one and the null set is always a subset of that one. Generally, we call them as trivial. Some books give that name, trivial subsets. In your NCERT book, it's not given here. So for any set A, the set itself and the null set are also subsets of that set, which are generally called as they are trivial subsets. Because whatever may be the elements, these 2 will always be present. The set would be there, the null set would be there, which we call them as the trivial. That means it would be always there. For any set it would be there. That is the meaning of that one. We generally call them as trivial subsets. Now let me consider some problems. That is, just now I told you, the problem would be find all the or write all the subsets of the given set. That's the meaning of this one. Let me work out some problem. Write the subsets of, that is the problem would be asked like this. Write all the subsets. Write all the subsets. All the subsets of the given sets. Right? All the subsets of the given sets. Now I'll take first set A containing only one element. It is a singleton. Set A contains only one element. How to write the subsets? Subset means it is also a set. So you have to write in the form of a set, the usual notation, writing the elements inside the flower bracket. Okay. Now take, how many elements are there? There is only one element. Just now I said that for each set, the trivial sets are the set itself and the null set. So first I write phi and then the set A. because it is containing only one element. So I could write this as the set A itself. So how many subsets are there? There are 2 subsets here. Now let me take another set, say B, containing 2 elements. Containing 2 elements. Here there was only one element, it was easy. Now let me take 2 elements here. Now first let me write the null set, because it will be always there. Null set, that means null set is always a subset of any given set. Now there are 2 elements. Take one element at a time, that is the set containing only 1. Then the set containing only 2. You observe, it is a set, you have to use the same notation. The flower brackets you have to use here. So it is a set containing one element. You can say 1 is a subset, that is if you call it as B dash, let us assume B dash is a subset of B. If you take it as B double dash is a subset, because 1 belongs to this set, 1 belongs to this set, 2 belongs to this set, 2 belongs to the set B. That means that 5 is a subset of B. Set containing only one element 1 is a subset of B. Set containing only 2 is a subset of B. Now take set containing both the elements. Just now I told you, for each set, the null set and the set itself will always be subsets, but we call as the trivial subsets. So in this one, how many are there? There are 4 subsets. Now let me take another example. Take another set C containing 3 elements, say A, B, C. Now let me use the same procedure. First always write the null set. Then there are 3 elements. Let me take one at a time. That is, take a set containing one element A, another set containing one element B, another set containing one element C. That means that though there are 3 elements here, I am taking only one at a time. You observe, it is a set here containing one element, that A is present in C also. So this set is a subset of this one, first one. Next, set containing only one element B is present here, so it is a subset. Another set containing only C is a subset of this one. Now come to the next. See, I have taken nothing here, one at a time. What's the next possibility? 2 at a time. That is, here take A comma B. I am taking 2 elements at a time. You observe, both the elements A and B, they are belonging to C also. So the set containing A, B is a subset of this one. Similarly, set containing B, C, set containing AC. Set containing AC is a subset. First I have taken null set. Now I have taken 3 sets singleton containing one element. All of them are part of C. Other 3 sets, subsets, because all those elements are present in the given set. So even all of them, they are subsets. And lastly, here I am having a set containing all the 3 elements. So nothing at a time, 1 at a time, 2 at a time, 3 at a time. Totally how many? 1, 2, 3, 4, 5, 6, 7, 8. That is 8 subsets I am having. So first set contained only one element. So I had 2 subsets of that one. Now the second set contained 2 elements. I am having 4 subsets. The third one, C, is having 3 elements. So the total number of subsets possible would be 8. Now let me take another example, D, because after observing all of them, I am getting one more important information. Now let me consider 3 elements here, say 1, 3, 5, 7. How many elements are there? There are 4 elements. So like this only, we start from the least number. First one, as usual, I take 5. Then here 3 elements were there, I took 1 at a time. The same procedure I am following. First I take 1, then take 3, then take 5, then take 7. Okay. So taking 1 at a time, I get 4 subsets. then take 2 at a time. 1, 3, 3, 5, 5, 7, then 1, 3, 3, 5, 5, 7, and then I am writing the remaining, then 1, 5, 1, 5, and then 3, 7, and then 1, 7, 1, 7. So 1, 3, 1, 5, 1, 7, 3, 5, 3, 7, and then 5, 7. So we have just considered all possible ways of combining two elements here. So take 1 at a time. I have taken 2 at a time. Then what's the next possibility? I can take 3 at a time. That is like this. It is 1, 3, 5, then 3, 5, 7, then 5, 7, 1, then it is 7, 1, 3. 7, 1, 3. So there are 4 possibilities here, 1, 3, 5, 3, 5, 7, 5, 7, 1, and 7, 1, 3. Can you write some more here? Look here, 1 at a time, 4 possibilities, 2 at a time, 6 possibilities. See here, 1, 3, 5 we have taken, and 1, 3, 7. Then 3, 5, 7, and 5, 7, 1. Now these are the 4. Then what is the other possibility? I have taken nothing at a time, then 1 at a time, then 2 at a time, then 3 at a time. Last possibility is all of them. That is 1, 3, 5, 7. That means the set itself. I have told you always, in between subsets may be there and may not be there. The given set and the null set will always be subsets. Now let me take the total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I am having here totally 16 subsets. Now usually maximum 4 elements would be given to you, and you will be asked to find the subsets here. For a 2 mark question, either 2 or 3 elements would be there. For a 4 mark question, for a 3 mark question, there would be 4 elements. So you will be getting all the 6 of them. Now look at all of them. Here one element, we had 2 subsets here, the null set and the set itself. When there were 2 elements here, null set, set containing 1 element, set containing 2 elements, the set itself I mean. So we had 4. Consider the third one. There were 3 elements, the null set, the subsets containing 1 element, subsets containing 2 elements, and the subset containing all the element, that is the set itself. Same thing here, 4 elements, the null set, the subsets containing 1 element, subsets containing 2 elements, subsets containing 3 elements, and the set itself. So totally 16. You observe all these numbers, 2, 4, 8, 16. If you take one more element, 5 elements here, the number would become 32. There would be 32 subsets. How do you connect these numbers? When you look at the numbers 2, 4, 8, 6, clearly we observe that 2 can be written as 2 to the power 1. Now here you can write it as 2 to the power 2. Now this can be written as 2 to the power 3, and this is 2 to the power 4. Now this can be generalized. Now look at the indices. All of them have got the same base 2, isn't it? What are the indices here? The first one, the index is 1. How many elements are there? It is only 1 element. Take the second one, 2 to the power 2. Don't worry about the base. I am worried about the index here, considering only the index here. The index is 2. Now how many elements are there? 2 elements. So the number of subsets is 2 to the power 2. 1 element, the number of subsets is 2 to the power 1. How many elements are there? 1, 2, 3. We are having 2 to the power 3. That is, if there are 3 elements, the total number of subsets would be 2 to the power 3. If there is 1 element, 2 to the power 1. 2 elements, 2 to the power 2. 3 elements, 2 to the power 3. 4 elements, it is 2 to the power 4. So in general, I can say, if there are m elements, in a set, Okay, then the total number of subsets would be 2 to the power m. So this can be generalized. Suppose there are 5 elements here, A, B, C, D, E. In that one, it is 2 to the power 5. How much that would be? 32. Suppose there are 6 elements, 2 to the power 6, that is 64. So the number of subsets will always be 2 to the power that number. What does the index denote here? Index denotes the number of elements present in the set here. That is, I have given you in the previous session, I have mentioned one word, cardinal number. That is, if a set contains, say, 2 elements, no, we write it as n of a is equal to 2. Now, if it contains m elements in general, n of a is equal to m, then we say there would be 2 to the power m subsets for that particular set. Now, this information always you have to remember. See, if, you can expect in any competitive examination for a 1 mark question, competitive examination 1 mark question only, that is how many subsets would be there for a set. Suppose a set contains 10 elements. Now what is the number of subsets? In that case, directly you can write 2 to the power 10 like that. So no thinking, if you remember the formula here, then easily you can write the number of subsets that particular set can have. So in general we can say if there are m elements in a set, the total number of subsets would be 2 to the power m. Okay. Now suppose I am considering a set which does not contain any element. That is, what you call them? What you call it? A null set. It does not contain any element. So how many subsets can exist here? Only one, the null set itself, isn't it? How do you write that one? No element means 2 to the power 0. No element means the index is 0, no element at all. What is the value? 1. So that is what we get here. So it depends upon the number of subsets a set can have, depends upon the number of elements the set is having. That can be generalized. Now I am defining one more word. It is called as power set. It is called as power set. What do you mean by power set? It is defined as, the definitions are usually not asked here, you should know that one. Power set means it is a set containing all the subsets of a given set. Suppose the given set is A. Now the power set of A is a set containing all the subsets of A and denoted by P of A. P, capital P we use, that means P of A. In the first problem just now I had given P of A. How many elements did I get here? 1 is 5. But when I am using the word set here, it has to be written in the form of a set only. The set, that is null set, the other one is like this. You have to write like this. So power set means it is a set containing all the subsets of the given set. In the same example, in the second example, suppose I write B, P of B. What are the elements here? One is a null set, another set containing 1, another set containing 2, and then next one is containing both the elements. So in this one, see, each element itself would be set. So set has to be written in the form of a set only, that is using the flower brackets here. So this is the power set of P, that is the second example I had given. Similarly, if you take the third example, P of C would be containing the null set, set containing one element, A, B and C, set containing two elements, A, B, B, C, A, C, and the set containing all the elements, that is a set itself. So it will be having 8 elements. So this is the way we have to write, that is power set of A is a set containing all the subsets of a given set. The notation is capital P of whatever set is using. So how do you write that one? If n of A is m. What do you mean by that one? This is the, again, this n of A means we call it as the cardinal number. This can be used only for a finite set here. So if a set contains m elements, if n of A is equal to m, then we write n of P of A. This notation we use to write the cardinal number, how many elements are present in the set. If a set contains m elements, then the power set of A contains 2 to the power m elements. This you have to remember. If n of A is equal to m, n of P of A will always be equal to 2 to the power m. So this is called as the power set of A. So the question can be asked like this: write all the subsets of A. Then you have to write like this, individually you can write. Suppose they ask you, write the power set of A, then all the elements have to be written in flower brackets, just like you represent any set here. Now, one more definition I want to give in this one, then I conclude this particular session. We call it a universal set. Universal set. This is one more definition. Now, universal set cannot be defined universally. That means, for all the sets, we cannot have a common universal set. Okay, universal set depends upon what type of sets we are considering. Now, generally, how do you define that is, in any discussion about the sets, the biggest set among them, we call it as the universal set. So, we cannot say this is the universal set for all the types of sets. See, we may consider the population, or we may consider the marks scored by the, some other, say animals, we can say animals, the easy example. The number of people we can consider, the number of animals we can consider, number of students in a class we can consider, or the numbers, the positive, integer, negative, like that we can consider, number systems I mean. So whatever may be the types of sets we are considering, the biggest among them is called as the universal set, and we use the capital letter U to denote a universal set. So we cannot have a common universal set for all the problems that we will be discussing. It depends upon what type of sets we are considering. For example, suppose you are considering the odd numbers, the even numbers, or prime numbers. We are considering the odd numbers, even numbers, and prime numbers. For that, you can take the set of natural numbers as the universal set, because odd number is a natural number, even number is a natural number, prime number is also a natural number. So we can take all of them as part of this one. So when we consider these numbers, the set n becomes the universal set for this particular type of discussion. Similarly, suppose you take a discussion about the numbers in general, not even or odd like that, then the set R, what is that one? The set of the real numbers, it becomes the universal set. So for any other discussion about the number systems, the set of real numbers will become the universal set. Of course, there is one more set, what we call as a set of complex numbers. You will be studying in the coming topics about that one. At present, you know only about a real number, so I am confining only up to that one. So here the set of real numbers becomes the universal set for all the discussion about the set number of number systems or number sets, okay, sets of numbers I can say. Similarly, suppose you are considering the population. If you are taking the population of the states of a country, then the population of the country becomes a universal set. Suppose you are considering the population of a continent, then the population of the different countries, population of the continent becomes a universal set for the population of the countries. Suppose you take the population of the whole world, then all the continents, the population of the continents come under that one. In that case, we take the population of the whole country, whole universe, I mean, we call it the whole world, I can say, whole world, we take that as the universal set. So generally, any discussion, we take the biggest among the types. I told you already, it may be number, it may be students, it may be people, it may be animals, whatever may be that one. Whatever type of quantities we are discussing, among them which is the biggest, it is called as a universal set. So while working out the problems, no, the universal set would be given to you in the problem. Say for a particular problem, the numbers 1 to 25, that becomes the universal set. They give that in the problem. So taking that as a universal set, whatever other things that have been asked in the problem, you can do the calculation depending upon that one. So in today's session, what are the things we have learnt? We have learnt about the definition of a subset, that is considering two sets A and B. If each element of A is an element of B, we say A is a subset of B. It so happens that if A is a subset of B and B is also a subset of A, we say A and B are equal to each other. And the notation for a subset is we belongs to means there would be in between one line. So without that one, it becomes the notation for a subset. Now if A is a subset of B and if A is not equal to B, we call it as a proper, A is a proper subset of B and B is called as the superset of A. Now for each set A, irrespective of the number of elements present in the set, it will be having the basic null set as well as the set as the subsets of that one, which we call as the trivial subsets. Now after learning what are the different subsets of a given set, a set containing one element will have two subsets. Set containing two elements will have four subsets. Set containing three elements will have 8 subsets. Set containing 4 elements will have 16 subsets. So observing all of them, we come to the conclusion that if a set has m elements, then the number of subsets it will have would be 2 to the power m here, depending upon the number m there. So if it is having 10 elements here, the total number of subsets would be 2 to the power 10. They won't ask you to write all of them. 2 to the power 10 becomes quite a huge number. So they will ask you how many subsets would be there. Then you can directly write 2 to the power 10. The next is the power set, that is the set containing all the subsets of a given set is called as the power set, and you can write P, capital P of that one. Finally, the universal set. Universal set means in any discussion about sets here, the biggest among them, what type of sets we are considering, that we have to think, biggest among that particular type of elements here, that is known as the universal set, and we use the capital letter U to denote the sets. In the coming session, I will be teaching you about the other topics here, that is interval as a subset, and then we will be learning some more operations. Operation means you know the basic operation, addition, subtraction, multiplication, division, like that. We call them as fundamental or the basic operation. We can do them with the numbers here. But set is a different algebraic structure. We cannot use addition or subtraction because here it is a collection. It is collection of numbers we are having. Therefore, we discuss about different type of operation on the sets, how to operate, how to combine two sets like that. So that will be discussed in the coming sessions. Thank you.